In this video, we are going to learn how to determine whether or not a relation is a function using something called the vertical line test. The definition of the vertical line test is as follows. So if you are given the graph of a relation, and if you can draw a vertical line that intersects the graph of the relation at more than one point, then the relation is not a function. On the other hand, if every vertical line that you could draw, intersects the graph of the relation at most 1 point, so either 1 point or less than 1 point, then the relation is a function. As is often the case, the best way to understand this concept is to do some examples, so let's do that next. Here we have a few functions or a few relations that are expressed as a graph. So these are the graphs of these relations. And we are going to use the vertical line test to determine whether or not the relation is a function. And then we are also going to practice stating the domain and the range of that relation. So let's start with number 1. In number 1, let's draw as many vertical lines or a couple vertical lines in this function, and let's see how many different places it hits the graph. So this is an upside down parabola. And notice as I draw vertical lines, no matter where I draw them through this graph, they are always intersecting the graph in exactly 1 point. Okay, and you can kind of tell by looking at this, no matter where I put my vertical line, that vertical line, again, will only intersect the graph of the relation at exactly 1 point. Okay, so again, looking at our definition of the vertical line test, if you can draw a vertical line that intersects the graph of the relation at more than 1 point, the relation is not a function. If every vertical line intersects the graph of the relation at most 1 point, so 1 point or less, then the relation is a function. Since every single vertical line that you can draw intercepts the graph at most 1 point, in this case, this must be a function. Every single x value is paired with exactly 1 y value. All right, let's move on to find the domain and range. Okay, so again, looking at this graph, one thing to note is that we have an arrow going here which is going down and to the left. That means even though we can't see where this graph is going, it is going to keep going to infinity towards the left and towards negative infinity going down. On the right, we have an arrow that's going down and to the right. So again, this will continue to go to positive infinity on the right and negative infinity going down. So first, thinking about all the x values, again, it's going to keep going to negative infinity on the left. There are no holes in this graph, and it'll keep going to positive infinity on the right. So our domain, all of the x values, of this function are from negative infinity all the way to infinity. In other words, it is all real numbers. The possible inputs in this function are any real number. For the range, you can tell that this function is going to go to negative infinity, so it's going to keep getting smaller and smaller all the way to negative infinity. However, you can tell that there is the highest point, and the highest point is right here. And if we count 1, 2, 3, 4, we see that the highest point is right here, and that point is the point -1, +4. Okay. The y values do not get any higher than 4. They can get as small as you'd like, but they don't get any higher from 4. So the way we express this is that we put in, again, interval notation. What is the smallest possible number? The smallest possible number in this function is negative infinity. The largest possible value for the y value is +4. Now, since 4 is actually that y value will get hit, that is an output of this function, we're going to put a square bracket so that we indicate that this will be all the numbers in between negative infinity and 4, including the number 4. All right, let's look at the next one. All right. Again, let's do our vertical line test here. If I draw a vertical line right here, automatically we see that this vertical line crosses this graph at more than 1 point. It actually crosses it at 2 points. If you can do that, we know automatically this is not a function. This relation is not a function, right? The way you can think about this is like this. These points, this is 1, 2, 3, 4. So this point is for -2, and this point is for +2. As you can see in this relation, my input of 4, if I plug in x equals 4, there are 2 possible outputs for this relation, either +2 or -2. And remember, our definition of a function is, the way we know a relation is a function is every input has only one unique output. The input of 4 has 2 different outputs, +2 and -2. So we know it is not a function. One small thing, notice that not every single vertical line crosses the graph at 2 points. For example, if I draw this vertical line, it actually only hits the graph at 1 point. And if I draw this vertical line, it actually hits it at 0 points. But that's irrelevant here. In order for us to know that something is not a function, all we need to do is find exactly one vertical line that crosses the graph at 2 different points, and that is enough to determine that this is not a function. All right, let's talk about the domain and range. So my x values, right, here's my graph. And so the smallest x value that's on that graph happens right here. And remember, this point right here is 0, 0. That's the origin. So the smallest possible x value is 0. And 0 is on the graph. That is one of the y values in this relation. So we'll put a square bracket. As you can see, this will keep on going to infinity towards the right. And so the biggest x value, well, it's just going to keep going till infinity until infinity. And so we will use infinity for the maximum value of this function, or of this relation, I should say. And we put a curved bracket next to infinity always. Let's talk about the range. For the range, again, since this arrow is going up and to the left, this graph, as it goes farther and farther to the right, will keep going upwards as well. Similarly, since this part of the graph is going down and to the right, as it keeps going to the right, it's going to keep going further and further down. Okay? And so as you enter in larger and larger x values, you will get larger and larger y values, as well as you'll be getting smaller and smaller y values. Notice there's no holes on this graph, and so all of the possible y values, the range of the possible y values in this relation will be from negative infinity all the way to positive infinity. In other words, all real numbers. For number 3, we're going to do the graph of a circle. So let's go ahead and draw this very quickly. And I'll try to draw the best circle I can. All right. And I'll put a couple points that are going to be on here. Okay. So in this case, our relation is the graph of our relation is a circle. Again, this is fairly easy to see that if I draw a vertical line anywhere in the middle of this circle, it is going to hit the graph in 2 different points. Okay, so again, automatically we know this is not a function. Now, what is the domain and range? Well, notice that the x values are really in between here and here, going left to right. All the x values will be in between these 2 values. So if we count, this is -2 right here, and this will be -3, -4, -5, -6, -7, and this is -8. So all of our x values will be in between -8 and -2. So our domain will be in between -8 and 2. And both the x value -8 and the x value -2 are on that graph, so we want to use the square brackets when we use interval notation here. Similarly, the range, you can see, goes between here. The y values, the highest y value is right here. The lowest y value is actually right here. The lowest point is actually on the x-axis. So that means this is the smallest y value. Well, the x-axis, that is y equals 0. So that's the smallest possible y value. And the largest y value, I'll have to kind of count this out. This will be 1, 2, 3, 4, 5, 6. And so that's my domain and range. All right, we'll do one last example. Again, let's try the vertical line test. Notice, again, no matter where I draw my line, my vertical line, it is only intersecting at one point. Now there is one slight complication, which might be if I drew the graph, this graph is asymptotic to the y-axis. On the left-hand side, it keeps getting closer and closer, though it never quite crosses it. And on the right-hand side, the graph gets closer and closer to the y-axis going down, but never quite crosses it. So this line right here actually doesn't intercept the graph anywhere. On the left-hand side, it gets closer and closer to the y-axis, but it doesn't touch it. And same on the right-hand side, it gets closer and closer, but never touches it. So for that reason, again, every vertical line here either crosses the graph at exactly one point, or this one right here through the y-axis, actually that vertical line does not cross it at all. For that reason, we can say that this is not a function. I'm sorry, this is a function. So and let's find the domain and range. All right, so again, you can tell that on this graph, this left-hand part of the graph is going to keep going further and further to the left. So it's going to get to negative infinity. But notice that this gets closer and closer to 0, but it never quite hits it. So the left-hand side of that graph will be all the x values in between negative infinity and 0. But 0 is not actually one of the x values that we have on this graph. Nowhere on this graph is x equal to 0, so it gets closer and closer to it, but it never quite hits it, so we use a curved bracket here. Now that is only the left-hand side. We need to put that together with the right-hand side, so we're going to use what's called a union symbol here. That means basically it's saying that our domain will be all the numbers between negative infinity and 0, and we'll decide what the right-hand side, what are the x values here? Well, it goes from, again, it goes all the way to positive infinity on the right, and then it gets closer and closer, but never touches 0 as it goes to the left. So it'll be in between 0 and positive infinity here, and that's our domain. Our range will be a little bit similar. Again, looking at this left-hand side, it obviously goes to positive infinity, and it keeps going, but then it takes a left turn, and it keeps getting closer and closer to the x-axis, but never quite gets there. So my y values get closer and closer to 0, but never quite hit 0, and shoot up to infinity. So this left-hand side is in between 0 and positive infinity. And so we'll put this on the right. And this left-hand side, my y values get as small as negative infinity. This keeps going to negative infinity, and it keeps going up and up and up until it gets closer and closer to 0, but it never quite hits it. So that's in between negative infinity and 0. Okay. All right, so those are a couple examples. That's how you use the vertical line test.